Hey guys, I'm back to talk about composition of transformations today. Shelby asked if I would tell a joke, but that might have to wait till tomorrow. What compositions of transformations are is when we basically just when I do more than one transformation in a row. The only thing that's new is that we're going to think about doing those multiple transformations as the final product is just being one transformation. Okay, so the most important thing to realize as we go through this is just the order of the transformations is very important. And so again, the goal is just to write multiple transformations as one thing. Okay, so let's look at an example. This first one here says to describe the composition of transformations as one single transformation. And you see here some notation. There's a translation of right 6 and down and up 4, and then there's a reflection over y equals x. Let me talk about this notation a little bit. This little circle right here means of. Okay, so what we're doing here is we're taking the translation of the reflection. In other words, the result of the reflection is what I need to translate. So when you see this notation, it's kind of strange, but this is the reflection is what we do first, and the translation is what we do second, even though that you see the T first, because we want to take the translation of the reflection. So we're going to look at some of this graphically in just a second, but I want to realize that since this is something that we're already familiar with, both of these transformations, I know that if I reflect across y equals x, I know the rule is that my point xy would become the point yx, right? And so what we want to do is translate the result of this. So my yx is going to be translated. And if I move to the right 6 units, my x-coordinate, which is represented by the letter y right now, would be added by 6, and I would add 4 to my y-coordinate, which is this x. Okay? So the result here is that I can write this composition of transformations, multiple transformations, as just one rule, right? And so what we have is that the function xy becomes, or the point xy becomes the point y plus 6, comma x plus 4. And that is one transformation that describes what's happening. I know that it's a little strange to see the y added by 6 means to the right, but it's because we've already switched it because of the reflection. Now, like I said a second ago, the order is really important. So I want to take a look at the exact same transformations, a reflection over y equals x and a translation, but in the opposite order, and see what happens. Okay? So the first thing I would do, again, is my translation here. So I want xy to be moved to the right 6 and up 4. And then I want to take the result of this translation. I don't know why it's writing at the bottom there. And I want to reflect that, which means I need to switch my x and y coordinates. So x plus 6 and y plus 4 are going to switch, and I get y plus 4, comma x plus 6. So this means that my final answer, my final composition here, is xy turns into y plus 4, comma x plus 6. Now, the point of this is that these two things are very different. Not very different, but they're different. Okay, the order absolutely matters. You do not get the same resulting transformation when you change the order. Sometimes you might, but that would be kind of coincidental. So just be aware of that, and it's really important. So let's look at another example with some graphs. All right, so this one is giving us a pre-image and wants us to shift this triangle down 3 units, then reflect across the y-axis, then rotate 90 degrees. And we could do this with coordinates, but let's just do it with the picture. Okay, so first I'm going to shift this thing down 3 units. So A prime, B prime, and C prime would be right here. Okay, then I would reflect across the y-axis. So as I do that, I'm going to land over here. Right, it's just my x-coordinates are changing sign. All right, and I'm going to go ahead and erase my first translation. And so now the question is, what happens when it rotates around 90 degrees? So around the origin, we know that you can do this with your rule, or we can do it by perpendicular lines. This is up 1 and right 1, so it's going to land here. This one is up 1 and right 4, so I need to go up 4 and left 1. And this guy is right 1, down 3, so it's going to be up 1 and right 3. Okay, so here is my final image there. Okay, so again, this is, I didn't really do this right. This is B prime, that's A prime, and this guy is C prime. Okay, so obviously it's not as big of a deal when it just tells me what to do in order. We just follow the order. If I were to write this with that other notation, I do think it's worth writing this out. Remember, the first thing I do is actually what goes furthest to the right. So what we did here is we did a rotation of 90 degrees of a reflection over the y-axis of a translation down 3. Okay, so it would be in this order because, again, the result of the first one is what I'm doing, what I'm using as my pre-image for the second one, and so on. And so I know that's a little strange, but I wanted to expose you to this in case we see it on exams or anything. We could also come up with a rule for this, but I guess it may be worth doing. So the idea is we went from xy to xy minus 3. That was our translation. Then that was reflected across the y-axis, which meant my x turned negative. So I have negative x y minus 3. And then that was rotated 90, which is, remember, we switched the y and x, and the y becomes negative. Okay, so that means I have to change the sign. So this is going to be y minus 3 comma negative x, but this, my original y coordinate, changes sign, so I need to multiply it by a negative. And so my final rule, if I did this all at once, would be xy becomes negative y plus 3 comma negative x. If you want to try this one on your own, you can pause it and give it a shot, but can we find the rule for this guy? Rotate by 90 degrees, then reflect over the x-axis, then reflect over y equals x. We want to see what that's the same as. You can, if you have a problem like this and you don't like just doing it using the rules, you can always plot a point or something too and say, okay, let's say I have this random point. If I rotate 90 degrees, it's going to land over here, and that can help you with the rules. So we know rotating 90 degrees, we just did this, is negative yx. Then reflect across the x-axis, right, which would take us down here. We know what that does is takes our y coordinate, which in this case is the letter x, and make it negative. The x does not change. Okay, and then I want to reflect across y equals x, which is, you know, this line here. If we remember, what happens there is we switch our coordinates. So the coordinates were negative y, negative x. They switch and become negative x, negative y. So our rule in this case of the one composition of all of these as one function would be xy turns into negative x, negative y, which hopefully you realize is the rule for a rotation of 180 degrees around the origin. So sometimes a composition of several transformations that seem unrelated can get us to one special one that we already know. And so you can kind of see, if I had reflected it here, that it would have, I don't know what's going on there, this point would have landed here. And you can see how that's a rotation of my original point by 180 degrees. So tomorrow we're going to practice this stuff and then eventually focus on some specific ones that, like this, that tell us a special transformation when I compose them. Thanks a lot.